So let's do, I don't know, let's do a cylinder. A cylinder kind of looks like this. Okay. If I was to ask you to find the surface area of this cylinder, what would you do? Well, the first things you would do is define your coordinate systems. So what's the coordinate system that would work the best? R, phi, z. Where r is the radius, phi is the sweep angle that makes it go around, and z is the height. So if I was going to ask you to find the surface area, what would it be? So my dA, which is my area element, will be made from d phi, my area that's being swept, times dz. There's a problem. How many surfaces do I have when I want to talk about a cylinder? Well, I have two surfaces that are circular. Very good, Nick. Two that are circular and one that is curved. Now, how do I account for all of those things? So this will give me my one area spheres, right? My curved surface. I also need two circles. What would they look like? Those dAs, let me call it 1, will be dr and r d phi. Do we all know where r d phi comes from? It comes from the fact that I'm moving around in a circle and I'm moving in a direction ds. Right? When we talked about circles, if this is r and I need to go this much, and that's phi, this is the displacement. And this is r. Do you remember that from Newtonian? Okay, so that means I will have two different surfaces. So my total surface area will be a combination of curved surface plus two circles. That means for my curved surface, I will get r dr d phi, 0 to r, 0 to 2 pi, plus 2. For my circles, I will get 0 to 2 pi d phi and 0 to h dz, and r will come out constant. So what will I get here? R squared over 2 times 2 pi plus 2r 2 pi h. Oh, wait, hold on. That should be replaced. This is my curved surface, so I'm going to move this over, and that will go here. Right, my curved surface should go in here. And so this will be different. This would be r 2 pi h plus 2 r squared over 2 times 2 pi. Does everybody get where I messed up? I put it in the wrong places. And that means these will get canceled, and I will get 2 pi r h plus 2 pi r squared. And in textbooks, or if you Google search it, it gives you surface area of a cylinder like this. Now you'll know where it comes from. What about volume? If I was to ask you to find me the volume, what's the volume element going to look like? dV will be dr, r d phi, and dz. Anybody want to do the volume? What will it be? This is actually going to be really easy. Integration of dV, integration of dr, integration, r d phi, and dz. So then I can separate them out. R dr, d phi, dz, 0 to h, 0 to 2 pi, 0 to r. What do I get? R squared over 2 pi h. Drum roll. What do I get? Woohoo. Oh, note one thing. When we were doing areas, how many integrations did we have? And when we were doing volumes, how many integrations do we have? 3. Excellent. Keep that in mind as we go through E&M, because E&M requires us all of these things, and we have to be careful about it, especially when we start talking about Maxwell's equations. Got it?